All right, so this is Redzone number 11. This is going to be a quick refresher of angle relationships. Angles tends to be a weak point for a lot of 8th graders, and that follows them into high school. So I want to go over it here, and hopefully you guys are paying attention and really trying to learn. The first thing, and I always ask my classes this every year, is what is an angle? And most people can't really define that. They give me types of angles, acute, obtuse, right, things like that, but they can't actually define what an angle is. An angle is the space in between when two lines meet at a vertex. So if I draw a line, and I draw another line, and you can see that they meet here at this vertex. A vertex is where two lines intersect, so right here. Now, the space in between the two lines is the angle. So the angle, and I'm going to draw it for you, is the space in between. And this is how you should get used to drawing it. You draw a little arc, a little curve from one line to the other. So that's what the angle is. The angle is the space in between the two lines. So the more space, the bigger the angle. So let me draw two more lines just to give you an idea. So here's a line, here's another line, and you can see again they meet at a point. That point is called the vertex. They meet right here. And the space in between the two lines is the angle. So again, I can draw that with an arc. And you can see that that space, since it was bigger, I had to draw a bigger arc, so this is a bigger angle. This one's called an acute angle, the one over here, because it's less than 90 degrees. This one's called an obtuse angle because it's larger than 90. So if you draw this arc pretty close to the vertex, it'll give you a good idea of how big or how small an angle is. Because, and the reason I say that, I'm going to draw two angles on this page. I'm going to draw an acute angle, like that. And I'm going to extend these lines pretty far, because it actually doesn't matter how far I extend them. And now I'm going to draw an obtuse angle, like that. And notice I didn't extend those lines very far. And the reason is because when you ask people which of these angles is larger, a lot of people will say this one because the lines are longer, but that actually has nothing to do with the angles. Remember that the angle is the space in between the two lines. So if I draw that angle marker, that little arc, the little curve, if I draw that in between the two lines, pretty close to the vertex, we'll see how big it is. So I'm going to try to draw it around right here, because you want to draw it pretty close to the vertex. So when I draw it there, it's a very small arc. I could draw it up here, but we don't really want to do that. You want to draw it close to the vertex. Now the same thing over here with this angle. I didn't draw these lines very big, but if I draw that arc close to the vertex, I can see that this arc, this red arc right here, is larger than this one over here. And I just also want you to notice, if I take this line and I extend it and make it longer, notice that that arc doesn't change. The angle doesn't change, just the length of the lines. So how long these lines are has nothing to do with angles. Okay, let's talk about angle relationships. Here's one of the ones you'll see. In 10th grade geometry, you'll see this a lot. You don't see it as much in 8th grade, but it does come up. Notice that we have one large angle, and this line in the middle breaks it up into two smaller angles. I'm going to draw one with a red arc. So you can see that this angle goes from here to here, and then that bottom angle I'll draw on a blue arc, goes from here to there. Oops, that was really messy. I'm going to draw that one again. There we go. So if I asked you which one's bigger, hopefully you would say the red one. If I ask you which one is smaller, the blue one. If I ask you these two angles together, what they add up to, hopefully you'd be able to tell me that they actually add up to become a right angle, because it's a perfect L. These kinds of angles are called complementary angles. Complementary angles are angles that add up to 90 degrees. You can tell they're complementary because they make this nice perfect L, and they normally draw that little like box for you. So that's complementary angles. The reason it's important to know that vocabulary word and to know that they add up to 90 is because if I tell you that this angle is 52 degrees, then I can figure out the blue angle. Since these two angles add up to 90, 90 minus 52 is 38. So this blue angle must be 38 degrees. Or if you wanted to write it as an equation, 52 plus the missing angle equals 90. And then this is something that you know how to solve, and you'll get the same answer. That brings us to our next situation. So this isn't that L 90 degree situation. This is a straight line. And something you learned about straight lines that you guys do a good job remembering is that straight lines, when we're talking about angles and degrees, equals 180 degrees. And a lot of you started like repeating that in Unit 2 when we learned how to graph lines. This is only important when we're talking about angles. You can notice again that they drew a line that intersects with the other one, and it creates two angles. I will draw them in red and blue again. So this first angle, I'm going to draw the arc pretty close to the vertex from there to there. And the second one I'll draw in blue, goes from here to here. Now, it's important that we get used to drawing these, because what shape do you notice these two arcs make when I put them together? They make a semicircle. And that's important because the semicircle is also 180 degrees. So if you look at this diagram, these two angles together, the red and the blue one, form a semicircle, and they lie on a straight line. Both of those things tell us that these two angles add up to 180. And we know a vocabulary word for that: supplementary angles. Supplementary angles add up to 180 degrees. It's important that we draw this because you will see a diagram where it's broken up into more than two angles. Call this 1, 2, and 3. And a lot of people think that angle 1 plus angle 3 is 180. Except if you look, that red angle and the blue angle do not form a full semicircle. You need to also include angle 2 in there. That's where we get this full semicircle. And again, that's why I like drawing those angle marks. That's how I show my classes. I know I tutor high school geometry. That's how those teachers showed their classes. When I took college geometry, same thing. You draw these angle markers. And it's important because angle 1 plus angle 2 plus angle 3 equals 180 degrees. In this diagram that we were talking about, angle 1 plus angle 2 equals 180 together because they form a full semicircle and they lie on a straight line. If you're not sure if something is a straight line or not, usually you can tell, but that's another good way of taking a look at it. So let me draw two lines here, and let me split them. So I have a red angle and a blue angle. And a lot of people might think that's 180 because it's like, ooh, we have this nice little semicircle here. But that's actually not a full semicircle. And the way I can tell is because if I trace the line on the bottom, that's not a straight line. So this is not 180 degrees. So those are some things to keep in mind. Now, if I told you that angle 1 was 150 degrees, you could then use that they're 180 and 150 to figure out that this one is 30. So let's take a look at the last situation before we do a practice problem. This is when two lines intersect. And when you see the two lines intersect, you see that they form four angles. I'm going to draw them in four different colors. Angle 1, angle 2, angle 3, and angle 4. And I drew them in four colors so that I can talk about them. Now there's a lot of different relationships here. And the first one I want to talk about is called vertical angles. Now, vertical angles, let me move this diagram over. Vertical angles are across from each other. And it's very important that they're formed when we have two intersecting lines. That's when we're going to see vertical angles, or more than two. So they are across from each other, and they are equal, or sometimes we use the word congruent. And this is the symbol for congruent, just if you remember. So if I asked you what is an example of two vertical angles in this diagram, there's two answers. You can tell me that angle 1 and angle 3 are vertical, and then also angle 2 and angle 4 are vertical angles. That means that angle 1 equals angle 3 and angle 2 equals angle 4. That's going to save us a lot of time. If I tell you angle 1 is 40 degrees, then right away, before looking for anything else and doing any kind of calculations, you can write that angle 3 is also 40 degrees. And the reason is because they are vertical angles. In 10th grade geometry, you have to do a lot of things with, they're called proofs. You have to prove things. And vertical angles are big in proofs. Okay, so I'm going to erase this definition. So hopefully you wrote it down, or you can pause the video. If you remember before, we talked about angles that make up straight lines. Well, I see some straight lines here. So we can talk about those types of angles. And we gave them a name before, and we called them supplementary. So do we see any supplementary angles here? Remember, supplementary angles have to add up to 180 degrees. And other ways to look at them, you look for straight lines, or you look for semicircles. I definitely see some examples of that in this diagram. The first one I see is angle 1 and 2. Let me switch to a highlighter. I'm going to highlight it for you. Angle 1 goes from there to there. Angle 2 goes from there to there. Is it a full semicircle? Well, let me check. That's a straight line. So yes, angle 1 and angle 2 are supplementary. Now that's important because if I needed to write an equation, I can write that angle 1 plus angle 2 equals 180 degrees. There are other examples. Angle 2 and angle 3 are supplementary. Angle 3 and angle 4 are supplementary. And angle 1 and angle 4 are supplementary. So I can write similar equations to this for all three of these other examples. So let me put an example on the board real quick. Here's a line. I'm going to intersect it with another line. So you can see we create these four angles. And I undid too much. I'm going to give you the measure of one of those angles. I'm going to give you the one on the left. I'm going to call it 35 degrees. And we want to find angle A, angle B, and angle C. So which one would be the easiest to find first? Well, angle B would be the easiest to find first, and it also equals 35 degrees. If I asked you why, a vocabulary word should pop into your head. They're equal because they are vertical angles. So that takes care of that. Now, how can I find angle A? It's not equal to 35. Angle A is actually equal to angle C, but that doesn't really help us because we don't know what angle C is. But what I do notice, here's angle A. I'm going to draw the arc I've been talking about. And we know that this one is 35. What shape did that just make? Well, it just made a full semicircle. And I know it's a full semicircle because this is a straight line. So I know that angle A and the angle next to it, the 35-degree angle, must add up to 180. So A plus 35 equals 180. I solve this equation and I get that A is 145. Or a lot of you don't like to do this with equations. You like to just do 180 minus 35 is 145. That would work, and that's fine, until we start giving more difficult 8th grade appropriate questions. For example, instead of 35, maybe I tell you that this is 2x plus 6, and instead of a, I write that this one is 4x plus 12. Then you can't do this. You'll have to do an equation. But we'll worry about that later. Now that we know that A is 145, then we also know that C is 145 because A and C are vertical angles. All right, so here's the first question. You have to answer, what is the relationship between angles 1 and 3? We just went over that. They are vertical angles. There's two answers here. They're vertical angles, which means that they are congruent. Both of these are correct, and I really want to see both of those things written down. What is the relationship between angle 1 and 4? Well, they are supplementary angles, which means they add up to 180 degrees. How do I know that? Because if I draw those little angle marks from here to here, from here to here, look at that, a perfect semicircle and a straight line. So that's how I know that they're supplementary and they add up to 180. All right, so before we get into the next question, one more thing we have to go over. What shape is here on the board? Scream it out loud if you're home. It'll make your parents question what you're doing. It's a triangle. Now we're talking about the angles of a triangle. So normally I would ask my class, what do we know about triangles? And they go, there are three sides. That's true. But we want to talk about the angles. That was bad. Hold on. One angle, two angle, three angles. And there's a fact about triangles that everyone should remember. The three interior angles add up to 180 degrees. And that is for any triangle. I can draw a random triangle. I don't know how big each angle is, but I know that together they all add up to 180 for any triangle. What's a word for angles that add up to 180? Supplementary. So again, the three angles of triangles are supplementary. This is helpful because if I give you two of them, you can then figure out the third one. You can do it by writing an equation, 100 plus 20 plus x equals 180, because the three angles of a triangle equal 180. Or you can do 100 plus 20 is 120, and then 180 minus 120 to get your answer of 60. So that's going to be really important. Now, there is a special theorem we learned about triangles. I know you love that word. Let me put it on a new slide here. All right, here's that triangle. Now, if I take this bottom line and I extend it, I create a fourth angle, but it's not inside the triangle. So again, we had our one angle, two angles, three angles, but now I have this fourth angle. Now I have this fourth angle on the outside of the triangle, and since it's on the outside of the triangle, we call this an exterior angle. And there's two things we know about exterior angles. Number one, an exterior angle and the angle next to it add up to 180 degrees. They are supplementary. You can tell on my diagram because this green angle and the purple angle form a perfect semicircle, a straight line. That's how I know they add up to 180. The second thing to know, and this is the theorem I was talking about, it's called the exterior angle theorem, is an exterior angle, I'm going to abbreviate here, equals the sum of the two angles not touching it. And there's a more mathy definition than what I just wrote, but that's what I'm going to go with. Let's call these angles A, B, C, and this purple one D. So to put it into an equation, what that would look like, angle D, the exterior angle, equals angle A plus angle B. So this one right here equals the sum of the two angles that are not touching it. So that's one way to find it. Or looking at number one, angle C plus angle D equals 180. All right, so let's move into this next question. Maya claims that angle 3 plus angle 4 equals angle 1. Now, we know that's true because angle 1 is an exterior angle, and we said that an exterior angle equals the sum of the two angles not touching it. Now, we just have to look at the choices and see why it's true. Basically, we're just seeing which ones are true and which are false. So choice A, angle 1 plus angle 2 equals 90. Those are these angles. But we just talked about that. Angle 1 and angle 2 equal 180, not 90. So that's wrong. And it also says angle 3 plus angle 4 equals 90. So that should be 180. And this, we actually don't know what that is. We need more information to know that. Which choice C also has that 90 there, so I can cross that one off. So now I look at B, angle 1 plus angle 2 equals 180. That's good. Angle 3 plus angle 4 equals 180. Here's another misconception. People go, oh, angle 3 and angle 4 are on a straight line. These angles are not next to each other, so you cannot say anything about a straight line. You could only say that angles add up to 180 on a straight line if they're next to each other. I can't just draw two random angles like this and say that they add up to 180. These two angles have nothing to do with each other because they're not next to each other. So choice B doesn't make sense. Let's look at choice D. Angle 1 plus angle 2 equals 180. We know that, check. And then 3, 4, and 2 equals 180. That's true because the three angles of a triangle add up to 180, so that's correct. Here's that other situation that we learned in Unit 1 that hopefully you remember a little bit about. It's called parallel lines being cut by a transversal. And when that happens, when you have these two parallel lines and you draw a transversal through them, it creates 8 special angles, which I am going to number 1, 2, 3, 4, 5, 6, 7, 8. These 8 angles have very special relationships. I'm going to move this over so I can write about them. Some of the things I'm not going to write are things that we already talked about. So, for example, I can see that angle 1 and angle 3 are vertical. We already talked about that, so I'm going to erase this. And angle 2 and angle 3 are supplementary because they form a semicircle, a straight line. Again, that should be something we already know. I want to talk about the new things that we haven't learned yet. And there are a lot of really good YouTube videos on this. There are some that are made by me or Mr. Viola, and then there are a bunch of random ones that you can find. So the first one I want to talk about are called corresponding angles. You've seen this word in a couple of different topics. You've seen it in this situation, you've seen it in similar figures. And you're going to see it again in 10th grade geometry, so it's better to get a good handle on it now. Corresponding angles are angles that are in the same position or location. So for example, if I look at these 4 angles, how would I describe where angle 1 is? Angle 1 is in the top left. Angle 2 is in the top right, and so forth. So now, if I look at the 4 angles at the bottom, which angle is also in the top left? Which one matches up with angle 1? Well, that would be angle 5. Angle 2 matches up with angle 6. Angle 3 matches up with angle 7. And angle 4 matches up with angle 8. So when you're talking about matching, that's corresponding. So all of these angles, not all of them, each pair of these angles are congruent. So for example, angle 1 and angle 5 are congruent. Angle 2 and angle 6 are congruent. That helps us because we already know that angle 1 and angle 3 are congruent. So that's going to tell us that angle 3 is also congruent to angle 5. That'll come up later. All right, so that's corresponding angles. If you need those notes again, just pause the video, go back and write them down. The next one I want to talk about are called alternate interior angles. Now, interior means inside, so the interior angles are the four angles that are in between the two parallel lines. So in this area here, this is the inside, and you can see that 3, 4, 5, and 6 are the interior angles. Alternate interior means that the angles that are diagonally across from each other, so angle 3 and angle 5 are alternate interior, and angle 4 and angle 6 are alternate interior. And again, these two pairs are going to be congruent. Another one that we learned is alternate exterior angles. Exterior means outside, so we're talking about the outside of the parallel lines, which means we're talking about 7 and 8 and 1 and 2. And again, alternate means diagonally across from each other. So we know that angle 1 and angle 7 are diagonally across from each other, alternate exterior, angle 2 and angle 8. And again, each one of these pairs is congruent. So you'll need those facts to answer some of these questions and when you're doing questions in high school. Am I missing any? No, I think that's good for now because you already know vertical and you already know supplementary. So the last thing I want to mention before we just power through the rest of this worksheet and go through all the answers is that if I give you any two angles, so if I give you, any two angles, they have to be equal or supplementary. There is no other option in this diagram. This is a very special diagram. If I give you any two angles, they have to be congruent, equal, or supplementary. So if I say angle 1 and angle 6, I just pick two random numbers. Here's angle 1, here's angle 6. Do they look equal? Some of you still need work with looking at angles and just telling if they're the same size or not. Angle 1 is an acute angle. It's a small one. Angle 6, look at that, it's an obtuse angle. So they are not equal, which tells me that they must be supplementary. If I needed to write this as an equation, I would write that angle 1 plus angle 6 equals 180, because that's what supplementary means. Another way to think about it is angle 1 and angle 5 are equal because they're corresponding. We just learned about that a few minutes ago. So I can really put a 1 there. And then I see that angle 1 and angle 6 are supplementary. So that's another way to look at it. All right, let me give you two more random angles. Let's try angle 3 and angle 6. No, we already did something like that. No, let's not do angle 3. Let's do angle 1 and angle... Yeah, I guess no matter what, it's going to come up, but angle 1 and angle 7. So I look, angle 1 is right here, angle 7 is right here. If I remember the vocabulary, I know that they are alternate exterior angles, so they are equal. They're both acute, so they're equal. Angle 1 is equal to angle 5, and angle 5 is equal to angle 7 because they're vertical. So that's another way I can tell that 1 is equal to 7. So an equation I would write would look like this. Angle 1 equals angle 7. All right, so let me make this a little smaller so it all fits on the page at one time. This is an old state exam question that combines two topics that we've learned this year. It says in the figure below, line DE is parallel to line FG with a transversal AG. Nothing super important in that sentence, just telling you that we have that nice situation with the parallel lines being cut by a transversal, so we have all those angle relationships. Write and solve a system of linear equations to determine the values of x and y. If you remember, in Unit 4 and in a previous Redzone, we learned that a system of equations is two or more equations that use the same variables. And you can see that we're dealing with x's and y's. Okay, so we have to write two equations here, or more, but we'll stick to two. So I have to look at these angles and see if I notice any relationships. Remember, the easiest one to look for, I'm going to use different colors here. If I go red for angle x over here, that angle, and I go blue for the one that's right across from it, what do we know about angles that are across from each other? They are called vertical angles. So this red and blue angle that I drew here are vertical angles. And what do we know about vertical angles? We know that they are equal. So x equals 5y minus 18. So there's one equation. Let me pick another color. Angle y down here is a little acute angle. There's a couple of different ways we can do this, but remember that I mentioned on the previous slide that if I give you two angles, they are automatically equal or supplementary. These two angles were equal. This angle does not look the same as those angles. It looks smaller, so it must be supplementary. So I have two options for equations. I can write x plus y equals 180. That would be this one plus this one equals 180. And I could do that because if this angle is x, then this angle over here is also x because they're alternate interior, and now I can see that they're supplementary. The other option, I can do that 5y minus 18 plus y is equal to 180 for a similar reason, but I'll stick with these two equations. So now I have a system of equations. We learned that there are three ways to solve systems of equations. One is elimination, and that's when the two equations are lined up perfectly and you have opposite coefficients so that you can add the equations together. This is not that. Even though it kind of looks like they're lined up, the equal signs in a different place, they're not lined up. The second way we learned how to solve is graphing. This is not a graphing because we don't have a graph and we're dealing with numbers like 18 and 180. It's going to be very hard to graph that. So the third way we learned is substitution. When one of the equations is given to you in this format, x equals or y equals, then you can use that to substitute information into the other equation. So I know from this first equation that x and 5y minus 18 are equal to each other. So in the second equation, where I see the x, I can get rid of it and replace it with 5y minus 18 because they're equal, they're the same. So it doesn't matter which one I write. I can write x, I can write 5y minus 18. Then I just bring down this plus y, and I bring down the equals 180. Why does that help us? It helps us because we don't know how to solve equations that have two different variables in them. They're impossible to solve. But we do know how to solve equations that only have one variable. So this equation here, this equation right here, and I'm just trying to move it, but it's okay, only has one variable. It's an equation we learned how to solve in Unit 1. So first I'm going to combine like terms, and I get 6y minus 18 equals 180. Then I add 18 to both sides. I get 6y equals 198. Then I divide both sides by 6, and I get 36 as my answer. So y equals 36. So that's half the battle. Now we have to figure out what x equals. So I'm going to use this equation to help. X equals 5y minus 18. But now I know that y is 36, so I use that. And now I just need to multiply. 5 times 36 is 180 minus 18, and I get x equals 162 degrees. So y, x, there are my two answers. Okay, so here's that more simplified situation we talked about earlier. So you need to find the value of each angle, so all four angles. But first you have to start by looking at the two angles that they give you information about. So what's the relationship between these two angles? Well, I notice that they are across from each other. What do we know about angles that are across from each other? They have a name. They're called vertical angles, and vertical angles are equal. That's where we need to get to. So I can just set these two angles equal to each other. 2x plus 7 equals 3x plus 2. Now we need to solve this equation. The first step is to get the variables together. So I'm going to do minus 2x from both sides. I have 7 equals x plus 2. Then I need to isolate the variable, minus 2 from both sides. I get x equals 5. Now a lot of you are going to stop here. That's not the final answer. They wanted the value of each angle. So I need to take this answer and plug it back into each angle. So first I'll look over here. 2 times 5 is 10. 10 plus 7 is 17 degrees. Now over here, 3 times 5 is 15. 15 plus 2 is also 17 degrees. If those two angles did not come out equal, then that means I messed up somewhere. Now I need to figure out angle 2. Well, I know that this angle and angle 2 add up to 180 because they form a straight line. So 180 minus 17 is 163 degrees, which means that angle 4 is also 163 degrees. All right, let's look on the right here of this question. These angles are next to each other, so they're not equal, they're not vertical. If I draw the angle marks, they form a semicircle, which means, let me write it to form a straight line or a semicircle. And that's important because we know both of those things are 180. So I know that these two angles add up to 180. So let's write that. 9x plus 25 plus x minus 5 equals 180. I don't need the degree symbol. Sorry about that. So now this, again, combine like terms. 9x plus x is 10x. 25 minus 5 is plus 20. Bring down the equals 180. Minus 20 from both sides. 10x equals 160. Divide by 10. X equals 16. Plug that into each angle up here. 16 minus 5 is 11 degrees. Plug it in here. 9 times 16 plus 25 is 169 degrees. So I know the one across from that is 169, and the one across from the other one is also 11. Okay, here we go. List all the alternate interior angles. So that would be angle 3 and angle 5. You can see that they are across from each other, diagonally across, and they're interior. So angle 4 and angle 6 are the other pair. List all the alternate exterior angles. That would be angle 1 and angle 7, and angle 2 and angle 8. The corresponding angles we said are the ones that match up. So angle 1 and angle 5 match up. Angle 2 and angle 6. Angle 3 and angle 7. And angle 4 and angle 8. And then list all the vertical angles. So angle 1 and angle 3, angle 2 and angle 4, 5 and 7, and 6 and 8. Okay? Here you go. If angle 1 is 2x plus 3, and angle 7 is 5x minus 32, find the measure of each angle. So the first thing you need to do is ask yourself, what's the relationship between angle 1 and angle 7? They are alternate exterior angles. And what do we know about alternate exterior angles? They are equal. So there we go. 2x plus 3 equals 5x minus 32. I solve this equation. I bring the 2x over. So 3 equals 3x minus 32. Add 32 to both sides. 35 equals 3x. Divide both sides by 3. And I get x equals a repeating decimal, 11 and 2/3. So I'm just actually going to leave it as a fraction, as 35 over 3. So to find the measure of each angle, I have to substitute that in. So 5 times 35 over 3 minus 32. And the other one was 2 times 35 over 3 plus 3. And I put that in my calculator. I get 79 over 3 degrees for both. If you leave it as a decimal, that's fine. It's 26.3 repeating for both of them. Sorry for the annoying numbers, but it happens. And that's it. So sorry for the long video. Hopefully you're using this to skip around to what you need. You should be trying the worksheet first, then using this video as a resource. Don't just watch the video and copy down the answers. Reach out to us when you have questions. We're only trying to help you get ready for high school. You have a month left here, so stay strong, keep putting in the effort. We're only asking for a little bit every other day. So do your best, join us live when you need to, and reach out with questions. Have a good day.